I'm really excited about the next few talks that we have. These are specific to open source projects. Next, we have Jason Meller, who's the CEO of Kolide. And I'm going to let him talk a little bit about Kolide, but it's built on top of the Osquery project. And I'm going to let Jason give all of us a better overview of what Osquery is and why it's so powerful. So thank you, Jason.
Thank you, Court. Awesome. So I actually learned the title of my talk this morning. It was called A Osquery Preview. That's what's on the agenda. And so I thought that would be like a nice theme for the talk, which is to have like an grammatically incorrect look at this incredible open source technology. So thanks everybody for coming and sticking around for after lunch. I know we're all kind of slipping into that food coma, but we are now entering the lightning talk portion of the festivities. So this is usually my favorite part of any conference because typically there isn't enough there's no filler here. We're just kind of going to go into a lot of open source projects, and I'm first on the agenda. So today we're going to be talking about an open source project called Osquery. Just kind of get a gauge of the room. How many people have you even heard of Osquery prior to this? Oh, nice. That's great. Okay, awesome. So hopefully today the goal is kind of get you introduced to some of the core concepts of Osquery, kind of give you a sense of all the tools and different things that are out there that can help you kind of take advantage of it today. And because it's a lightning talk, we're not going to really be able to get into it too deeply. But I'll be sticking around after the conference, and you can contact me at any time, and I'll have some additional resources for you after the talk. So my name is Jason Meller. I'm the CEO and co-founder of Kolide. My other co-founders are Mike Arpaia and Zach Wasserman. Both of them are former Facebookers, and Mike specifically is the creator of Osquery. And we were fortunate to have him and Zach both leave the Facebook security team to join me at Kolide. At Kolide, we build Osquery fleet management software. And today we're going to talk a little bit about Osquery, how it came about, why it was created, and all the fun stuff associated with just dealing with endpoint agents and all that fun stuff. So what be Osquery? Well, Osquery is an open platform for host analysis. So if you need to collect low-level information from a host, then you should use Osquery. Now, there's three properties to Osquery that really make it, I think, different from what the state-of-the-art is out there today. The first is that, as a feature, it is platform agnostic. When Osquery launched, it really took Mac OS and Linux as sort of first-class citizens in terms of the operating systems that it supported. And as recently as October of last year, it just introduced support for Windows. Now, what this means is that when you are actually trying to pull information from these hosts, Osquery does a great job of finding sort of a common playing field among them and utilizing terms and concepts that sort of lay neatly across all those different operating systems. And when you have to sort of dive deep into a specific concept that only exists in a single operating system, has really kind of detailed and opinionated ways of pulling that data as well. So if you're looking to sort of normalize your detection strategy across your endpoints and you want something that's really going to work across all the major platforms that are out there today, Osquery is a fantastic choice. Now, Osquery was created by Facebook back in 2014, I believe, and it was around that time period that it was actually open sourced by Facebook itself. Now, this is really awesome because if you think about all the different contributions that are going into Osquery today from an open source perspective, it's actually the community that's powering the majority of its development today. That includes companies, for-profit companies like Kolide and a bunch of other different large organizations that are using Osquery as an alternative to basically some of the existing commercial software that's solving this problem today. Now, the really awesome part about Osquery and what makes it such a great tool is that it was sort of incubated inside of this web-scale company. At Facebook, it runs on millions of production systems. And the amount of data that generates that has to be sort of sent somewhere and analyzed, if you do it not in a performant way, number one, you could actually affect the performance of the production systems that it's running on. So this thing is running on things that are powering Facebook Newsfeed, Instagram, Facebook Payments, and Facebook has an entire team that's just 100% dedicated to measuring how much compute they may be wasting when they add a new process to any single server in their infrastructure. And so when Osquery went out, it had to sort of pass that muster of being able to be performant enough where, some guy from their compute team isn't saying, well, because we've added Osquery, we're now wasting another, $30 million in compute because it's using this many, CPU cycles or this much memory. So Osquery sort of grew up in that environment, and with that amount of sort of data, flowing through it. So as a result, it's designed to run at scale, and that's what makes it really, really interesting for a lot of organizations that, they may not be Facebook size, but they sort of have, the vision to potentially get there one day. So this has a lot of repetition from what I just talked about, but there's a lot of interesting West Coast companies. So what Facebook did a really good job of when they released this and they open sourced it is they promoted the heck out of it. And so you have companies like Airbnb, Heroku, Netflix, Uber, Yelp, Yahoo, and even way more than that. They're utilizing this as one of the primary ways that they actually do endpoint detection at scale. And many of them are using it to defend and sort of monitor their Mac OS X fleets, and then also their Linux production server infrastructure. And what's really cool is that these companies have actually contributed back to the project, and I'll talk a little bit more about that. And many of them, especially Airbnb and Heroku, have actually created tools specifically for Osquery that make it a little bit easier to manage at scale. So we talked a little bit about what it is, but how does it actually work? And this is where Osquery gets really interesting and where it gets its name from. Osquery is basically an agent that sits on the computer, and it converts your computer into a relational database that you can query with SQL. And so if you think about all the concepts of your computer, you have the kernel, you have network, you have applications, you have processes that are running, you have all this stuff that's in your computer that you want to sort of inspect the state of. Osquery breaks all of that out into what it calls virtual tables that you can query. And so Osquery really ships out of the box with this opinionated relational schema that allows you to join things together and actually ask questions utilizing a language that's familiar to many, many people, especially sysadmins and DBAs. And so basically the example here, select star from processes, that essentially will, across all operating systems, enumerate a list of running processes and, include things like their PID, the path that it's running on, and things like that. And so there's tons of these virtual tables that are out there today. And what's awesome about Osquery, and because it's open source, you can contribute your own if there isn't something that you're looking for that isn't there already. So there's tables all over the place. This slide is horrendously out of date, but basically you have certain tables that are specific to certain operating systems. You have ones that lay across multiple operating systems, and you have some that are sort of like utility. So for example, they just introduced one recently called Wi-Fi survey. So this one's really cool. It only runs on Macs, and basically what it does is I can do select star from Wi-Fi survey, and it will go out to all the machines that are running Osquery and actually enumerate all the Wi-Fi base stations that the antenna can actually pick up. Now, what can you do with that data? Well, you can actually pass it to like Google Location Services, and even get the location of that computer remotely, which is really, really awesome. So there's hundreds of these tables, and utilizing all these different concepts, you can kind of pull this information together to solve a lot of real-world security use cases. So Osquery ships with two primary binaries. One's called Osquery I, and that's the command line interface. And so if you're on an individual computer that's running Osquery, you have this really awesome shell that allows you to just run queries on the fly and get the results back instantaneously. Now, this is a really important concept that I'm showing you on the screen here. So we've launched Osquery I, and we're doing a select star, or select hour, minutes, seconds from the time table. Now, time is just a utility table. All it's doing is when that SQL query is run, it goes into the Osquery schema, and then it's actually executing code on the endpoint to produce the result. So there's not like there's this sort of saved database that contains all the information sort of preloaded. Every time that you run an Osquery query, you actually end up running code that produces the end result that you're seeing on your screen. You can see that here. The first query here, the result was 10 hours, 18 minutes, 2 seconds, and then a few seconds later after running that, I could see the result has changed. This is true with the majority of the tables that are in Osquery today. So if I do select star from processes, or do select star from the network interfaces, I'm getting the most recent data at the time that that command was executed, which is really, really neat. So this is the power of Osquery. So this is another way that you can run Osquery. Osquery is basically, you can actually echo the SQL query and then pipe it out to Osquery. And Osquery, instead of that ASCII table that we just showed you, it can output to CSV, it can output to JSON, which is super useful. So here's just another thing where, okay, I'm just basically doing select name, PID from processes and limiting 10 there. And I could see 10 processes that are running just arbitrarily ordered right there in their associated PID. Now what's really cool is I can utilize that PID and I can now start joining things together to get more interesting information. So here I'm doing a select distinct, so I'm getting unique processes by name, and then I'm doing listening ports by port, and then I'm joining all that together utilizing the PID. And so in here I have basically a list of processes, and I have the associated ports that they're running on and the PID that join those two together. So I have now two tables that I'm basically looking at, listening ports and processes that I'm joining together on a PID, and here I'm able to produce really awesome results, which is just enumerating the processes that are running, what port that they're on, and what PID that they have. So as you can see, you can kind of build these questions that take multiple concepts within the computer, and it really kind of gives you a really nice, easy to predict way to sort of construct the question or the query that you want to ask. And this is the fundamental sort of power that Osquery brings. And if you have like the imagination and the ability to ask, you have the questions in mind that you want to ask, this gives you a really awesome, platform agnostic way to get the information that you need. So let's talk a little bit about use cases here. So there's several use cases that we see in the wild that people use Osquery for, and one of them is just doing basic signature-driven intel. So let's say I have a piece of Mac malware, and I kind of know how it persists itself. A lot of Mac malware will like to persist itself in launch D, and it'll create what's called like a plist entry. And usually certain malware will create a very unique sort of plist entry, and then basically you have to look for that specific thing, and if it returns results, it's there. So this is an example of a keylogger, and we know that it creates a plist entry, and we know that there's some variation in it, so we've used that % sign there as a wildcard. So we're doing where name like, and then based on that, we're able to find this specific variant of a keylogger with some degree of success. Now, if you're here for the keynote this morning, you heard Liam talk about sort of like David Bianco's pyramid of pain. So this would be like sort of something very easy that an attacker could change. And oftentimes, you could come up with hundreds or even thousands of these queries. Eventually, you're asking so many questions, and you're creating so many sort of signature-based pieces of intel that it can become overwhelming. In fact, at Kolide, we have a game that's basically we come up with like all these different playing cards associated with all the malware that we're trying to detect for our customers. And the stack just gets so large, the next thing that we do is we try to find common behaviors so that we can codify all the things that we're essentially looking for in this group of malware down to one single query. And so that's where use case number 2 comes in. And this is where the opinionated schema inside of Osquery really helps. Basically, I can find common malicious behaviors utilizing the actual schema itself. So in the processes table, there is a column called on disk. And basically what it will say is, okay, this process is running, but does it still have a file that's present on disk? A lot of malware, when it starts up, it will automatically delete itself and sort of remove its footprints, a very common behavior for malware to sort of exhibit. And so you can codify this behavior inside of a SQL query and then run it. And so we're able to kind of narrow down that stack, and now we have a behavioral-based query that's going to run across multiple potential Mac malware that we may find in the wild, or any malware in this case, because this is a platform agnostic query. So what's really interesting though is that you can really get pretty crazy with this stuff, and if you kind of have like the context of how a machine should behave, you could start looking for some really advanced stuff. And basically here, if endpoints have well-defined behavior, like they're supposed to be a server or they're not supposed to be a server, you could start looking for, different, remote ports that are not acting as a web server, and then sort of understanding what processes are associated with those things, and then enumerating a list of endpoints that aren't behaving in the way that they're supposed to behave. Now, this requires that you're sort of collecting how, a system behaves over time, and then within that context, running these queries and understanding when that behavior differs. And that's where like additional tools and different software can come in to help you collect this data, understand the patterns that certain assets in your infrastructure behave, and allow you to sort of detect when they sort of go outside of that norm. But this is a really awesome way of doing that. So the second thing that Osquery ships with is something called Osquery D, and that's the daemon. So everything that we've been doing right now, we've been just basically logging into one computer, and we've been basically just running a query and seeing the result in a console. Now that's not really useful because I probably have thousands of endpoints, and I don't want to just run one query at a time and just get the answers. I mean, that might be good for hunting or when I'm doing incident response. I kind of want to just log all the important questions that I have over time and then look through those logs later when something goes wrong so that I can go backwards in time and see what's happening. That's what Osquery D allows you to do. Basically, you supply this daemon at the configuration of a bunch of different queries that you want to run and what interval that you want to run them at, and the daemon takes care of executing those queries on that schedule that you've defined. Now, what's really awesome about this is that it utilizes this really highly performant database on your system. So like, for example, my laptop, if I close this and I go on an airplane without an internet connection, it's still running those queries and buffering them locally before it sends them out to some sort of collection infrastructure, so I know I'm not missing anything. So all these various problems that you have with like sort of asking these questions over long periods of time have been figured out with Osquery D. Now, sort of the standard MO for anyone who's running Osquery is you want to run Osquery D, you want to supply it with a configuration of all the important questions that you want to ask about your infrastructure, ask those on a regular interval, and then Osquery D is responsible for collecting all of that data and then sending it off to some sort of log aggregation infrastructure that you have in mind. So let's say you have Splunk or you're running the Elk stack, you can just take all that information, and each Osquery daemon can directly communicate with that log aggregation infrastructure, and then you can go backwards in time and really use all those collected logs to get the information that you need when you need it, versus having to just log into a computer and then run a single live query in the console. So Osquery D has some additional fun stuff that Osquery I doesn't have. It has what's called event-based pub subsystem. So remember when I said before, like when you run a query, it's telling you what's happening on the computer at that time. Now that's really awesome when you want real-time data, but if we're running off of a system where I'm asking the same question over and over, let's say I ask it every minute, and I'm looking for something like, let's say, I want to know when a process launched that could be evil. If I ask the question, the process launches after I ask it, and then it dies before the next time that I ask it, I've completely missed that window of opportunity to capture that malicious behavior. So Osquery D understands that there's certain questions that we want to ask where we want sort of an event log of everything that's happened. We want to query that thing instead of just queuing up the same question over and over. So things like process auditing, when processes launch, when they forked off, things like that. Hardware device monitoring. So when I've inserted like a USB key, and if say I remove it before the next query runs, like that's going to be a problem. So we have it there. There's file integrity monitoring, and there's just sort of this continuous Yara support. So if you have Yara rules that you're already utilizing today, you can throw them right into Osquery D. Now Osquery D also allows you to remotely communicate with it. So by default, you have to kind of pass it this configuration file, but there's an endpoint, there's a TLS endpoint where you can actually build like software that allows you to just push stuff to Osquery D, like a new configuration, and pull the results back, so you can communicate with all these agents remotely, which is really, really awesome. So this remote API is utilized by a lot of products today, Kolide included, but there's a ton of open source ones as well. So Doorman, Heroku Windmill, Zentrol, these are all solutions today that take advantage of this remote API. So if you're trying to get into Osquery and you want to kind of utilize something that can just kind of get you set up, and you can sort of enumerate and visualize the information that's coming in from these queries in a way that is somewhat useful to you and your team, I highly recommend taking a look at all these various solutions. And some of them have different kind of spins, like Zentrol marries a bunch of different open source projects together to kind of give you a very workstation-specific workflow. Heroku Windmill is just concerned about Osquery configuration and pushing that out. Doorman allows you to do like live queries and things like that. And so there's just a ton of awesome tech out there for running Osquery at scale and sort of taking away a lot of the cruft and guesswork when pulling together all these queries and configuration files, and it's super awesome. So with that, I know this was super quick, but there's a ton of information that I just glossed over. So if you want to know more about this and you don't have time to talk to me afterwards, I recommend you go to osquery.io. There's a ton of documentation there. We have a very, very active Slack community, so take a look at that. Kolide itself has put together kind of like a try Osquery page. So if you go to kolide.com/osquery, there's like a little console that you can interact with, so you don't have to install it or anything like that. Just kind of play with various queries that you want. Or you can always contact me directly, and we can get you in touch with me or Mike, who created the project, if you have any questions or concerns. Thanks. Yeah, so I think we have a little bit of extra time. I went through that pretty quickly. So if anyone has any specific questions about Osquery, you have me for the next 2 minutes. Brian. So Osquery D handles, yeah, sorry, yeah. So the question was, how does Osquery D handle authorization? So Osquery D can actually function in multiple modes. So you can run Osquery D with sudo to apply it with the various privileges that it needs, and it will do appropriate privilege dropping to specific users. For example, if you want to enumerate the apps that are only visible to certain users, you have the capability of doing that. So it's really up to you what type of privileges that you want to imbue Osquery D, and it will utilize those privileges to its full extent to enumerate the items on the computer that you're interested in. So if you don't give Osquery D sudo, it can still access everything that the current user that's running the process can see. But if you do, it can privilege escalate and drop as appropriate to get the information that you need. Did that answer your question sufficiently? Great. Yes. So the question was, does Osquery D care about the whole issue of can the malware tell that it's being scrutinized, or that their Osquery D is on the system itself? Yeah. So Osquery doesn't have embedded in it any sort of sort of debugging protection. It doesn't. To be fair, I haven't seen any malware in the wild yet that attempts to disable or try to hurt Osquery from running anyway. But yeah, so Facebook today hasn't been in a position where they've wanted to focus a lot of time and attention on that. But I personally believe that we're going to get into that cat and mouse game probably pretty soon. So to answer your question, there really isn't anything built into Osquery today to allow it to sort of mask its presence on the system, or to resist any sort of debugging or disabling from a motivated malware. Any other questions? Yes. Yeah, so the kernel module stuff today is a little bit shaky, especially on Mac OS. The kernel module support there isn't great. Yeah, we are doing a bunch of work at Kolide specifically to improve that, because a ton of our customers are really interested in kernel modules. And obviously, we want to make sure that we're competitive, or even going beyond audit D capabilities that are on the Linux side as well. So those are all sort of fundamental areas of focus for us, at least, and I know that just the greater Osquery community for sure. Awesome. Thanks, everybody.